Hello, my name's Owen Romney. I'm an open source engineer at Aqua Security. This is my first time presenting at HashiTalks, and in this session I want to talk about potential Terraform misconfigurations and suggest some ways in which you could avoid it. So what is a misconfiguration? Well, according to NIST, a misconfiguration is an incorrect or suboptimal configuration of an information system or system component that may lead to vulnerabilities. So that's to say it is a setting that may have been left as default. It may have been actively set to a value thinking that it would do one thing when it would actually do another thing. Or it could be a deliberate action that someone's trying to sneak through a change that could allow a platform to become compromised. So are there any high profile examples? Unfortunately, yes, there's an awful lot of them. I'm going to cover a couple here. In this case, February 2018, somebody found a Kubernetes console belonging to Tesla, and it hadn't been password protected, and it allowed the hackers to be able to get into the Kubernetes cluster. They were able to get onto the pods, and inside the pods, they were able to find AWS credentials. Now, once you've got the credentials, you've got all of the permissions of that set of keys, and you can either use them to traverse, or you can, if they've got enough permission, you can potentially do the attack that you want to do. Another example was Alteryx. This was in 2017, and this was the 36 gig file on S3 that contained data about 123 million households in America, and it had address information, it had financial data, it had purchasing information, so quite sensitive personal information. And that was a result of a canned ACL, and I'm going to go into a bit more detail on that shortly. Then the final example I've got here was Capital One, where 100 million credit card applications were compromised. This is a bit more involved. This one, the attackers were able to go through a misconfigured WAF. They were able to use an SSRF attack to get through the WAF and make a request against the Amazon metadata service. And the metadata service is what's used to vend the credentials. So once you've got your credentials, like I say, you can either traverse or you can carry out your attack. So how easy is it to actually get things wrong? Well, here's an example of an S3 bucket written in Terraform. So we've got bucket name, we've got ACL, we've got a configuration, we're using a custom managed key, we are logging, and we've got version enabled, so everything looks fine. Then there's this ACL, authenticated read. So surely that means that anyone authenticated within my AWS account can access my S3 bucket. So let's have a look at the documentation. So it says authenticated read, the owner gets full control, and authenticated users group gets read. Okay, well surely that's the authenticated users within my AWS account. Except there's also a warning in this documentation. When you grant access to authenticated users, that is anyone who's been authenticated across the world, across any AWS account against the AWS platform. So that means that someone totally unrelated to you, if they are authenticated against their particular account, now has access to your S3 bucket to read. So what could we do? Well, a slightly naive solution would be to set that to private. The realities of your use case, likely that the private access isn't going to be enough. At that point, you're looking at possibly having bucket or object policies. So is there any hope? Well, yes, there's quite a lot of solutions for static analysis. One of the better ones, tfsec. It's a static analysis scanner for Terraform. Specifically, it's for HCL scanning, and it also does tf.json files. It started around 2019. Liam and I have been a project owner since then. In July 2021, we moved under Aqua Security, where we're both open source engineers, and it now continues as an open source project, but under the custodianship of Aqua Security. So how did it come about? Well, it came about early 2019 when Liam was looking for a static analysis tool for Terraform that supported HCL version 2. he found an issue on one of the existing solutions. It was a stale GitHub issue where someone had said, please can you do v2 support? And he thought, well, okay, they're not doing it, so maybe I can do it. He also looked at the other solutions. A lot of them were using regular expressions to do some sort of pattern matching to look for errors. And from the outset, the intention was to be able to parse the HCL in the same way that Terraform parses the HCL, so that you could build the full model. So tfsec was started 2019. In November 2019, it was made public, the repo, and it very quickly became quite successful. If you use the fairly arbitrary metric of GitHub stars, it's been steady growth since then. So this is a fairly high level view of what tfsec does. We treat your Terraform files as a block of files, and rather than scanning a single file, we assume that in your Terraform it's made up of a number of files, be that variables, provider files, networking, TF, things like that. So we take the collection of files and they get passed into a parser. And if we find any downloaded modules in your .terraform folder, or any modules that you've created locally, and they're referenced within the Terraform that we're scanning, we load all of that in, so we've got a large model of all of the HCL, and then that gets passed into the evaluator. What the evaluator does is it takes each particular aspect of the model, be that a variable, a local, a resource, a data, and it looks at the references and it builds up the resolution. So if you have a variable default that's set to true, then we will make that resolution so that we know that that value in a default situation is set to true. Once we've got all these modules, we'll pass them to an adapter, and the adapter converts your Terraform into a common library that we've developed. The principle behind the library is it means that we can also convert CloudFormation, and the CloudFormation gets adapted into the same common logic, and we can run the same set of checks. And it doesn't really matter what templating language you've used, whether it be Terraform, Ansible, CloudFormation, we're able to scan it in a known format. So at that point, we run checks across all of our adapted resources. At this point, we bring in the ignores. So if, for example, you're not too worried about not having a description on a security group, then you might put an ignore just on that resource within your Terraform, and I'll go over that shortly. So we take into account any ignores that you've defined. And then finally, once we've run all of our checks, we report the results. You have options. You can spit it out in a normal, pretty format. You can get check style, JSON, Serif, JUnit, CSV. So there is a format that will suit your use case. So let's do a demo. What I'm going to do, I'm going to start with a fairly basic example. I'm going to use the same example from the presentation. So first of all, let's create a provider's TF. And in this, we will create our AWS provider. And we'll set the region to my region. So that's EU West 2. Now, if I do a Terraform init, great. So let's get rid of that. So if we start with our dodgy bucket again. So there it is. We've got the bucket, we've got the ACL set, we've got server-side encryption enabled. In fact, for this example, I'm going to get rid of that and I'm going to set it to AES 256. So just using AWS managed. We've got the logging and we've got versioning. So I need to install tfsec. And the best bet for that is if we go to tfsec dev, then it will take us through to the tfsec homepage. And then from here, we can go to the getting started, then installation. Our options for installation, if you are using Mac and you've got brew installed, then you can do brew install. That also works for Linux brew. That's fairly quick. On a new release, you'll get it about 6 to 10 hours after it's been released. Chocolatey and Scoop are your Windows installers. They're a little bit slower, but again, you'll get the latest or near enough to the latest release. Another option, you can go to the releases page on the GitHub project and you can download whatever your platform requires. Or you can use go install and you can install the latest version. It's worth pointing out on that, if you do that, you're using the development build and your version is set to development, and that means you won't be able to use the update mechanism. So if you want to be using update, you need to install it from one of the either the package managers or from the release page. Okay, so let's go back to the code. I have actually installed it. So if I do tfsec help, we can see there's quite a lot of options, but ultimately the usage is to pass it flags and run it against the directory. So let's get started. So if I run tfsec dot, then we can see that there's 7 potential problems. So let's start at the top. So we've got no public access block, blocking public ACLs. Okay, so that I think is asking for an S3 public access block. No public access block again, no public access block. So we can address this shortly. No public access block. Bucket does not encrypt with customer managed key. Okay, that's because we're using AES 256. Bucket is exposed to all AWS accounts via ACL. So this is what I was talking about in the slides. So we need to do something with that. And then again, it's another issue where we're not using a public access block. Okay, so what we can do is if we create ourselves a resource, AWS S3 bucket public access block, and we'll call that dodgy bucket public access block. And that is for our bucket is AWS S3 dodgy bucket ID. And then we'll set up some values. So we'll have block public ACLs. We don't want them. We will block public policies. So this will stop people putting public access policies onto the bucket. We want to restrict public buckets. And we want to ignore public ACL. So this means that if someone tries to do a public ACL, it will ignore it rather than blocking it. So in that sense, if someone does a put request, then it doesn't actually prevent it. It just doesn't do anything. Okay, so let's just clean it up. Now if we run a tfsec on here, we'll see we've now only got 3 potential issues. So what are our 3 issues? We've got the bucket's encrypted by a customer managed key. Okay, so let's sort that out. So we can do AWS KMS, and then in that case we'll need a KMS master key ID. Okay, so let's run that. So we're down to 2 problems, and it's we're still with this authenticator read and public ACLs. Okay, so I've made a typo in there, so that's good. So that's telling me that that should be ignore public ACL. And then while we're here, we will set our ACL to private. So this should be the last time we need to run this. tfsec dot. Oh no, we've still got 1 problem. Possibly that. Ignore public ACLs. There it is. Ignore public ACLs this time. There we go, no more problems. So that's all good. So the question is now, when should we be using tfsec? And there's a couple of points that you might want to use it. So if your misconfiguration is getting into production, then that's arguably too late. So where might you want to put it? You could put it into CI. So if we have a look at the documentation again, down here we've got a PR common interaction. So what this will do is it will, when someone creates a new PR, it'll go through the contents of that and if there's any issues, it'll comment them onto your pull request. Okay, here's our project. We've got tfsec, and we are going to add in our files. And in here we've got a provider which specifies the region. We have network, so that's got a VPC. We create a security group, and then we create a rule on the security group, and that's going to allow internet anywhere access on port 22. Then the last thing we're going to do is we're going to use an Ubuntu image, and we're going to create a Bastion instance that uses that security group. Okay, so let's check out a branch. Write some files. Let's add our files, git status. Okay, so we'll do a git commit, adding some files, and then git push. Now, just give it my key. So now what's going to happen is when we go to our project, we're going to see and create our PR. So we've got our Bastion, our provider, and our network. Let's create a pull request. Look at the checks, and we can see that there's a tfsec PR comment to check. And when this runs, what we're expecting it to do is we're expecting it to comment on the pull request all of the issues that tfsec finds. So what this is doing is it's running tfsec, and then it's running a commenter application that will use the results of tfsec, and it'll if the issue that it finds is related to the current commit, then it'll write it. So we can see here that it's commenting and it's broken the build. So let's go back to the pull request. We can have a look at stuff, and what we can see is that the GitHub action has written a comment on each of the issues, on each of the files. So in this case, we've got the fact that we haven't enabled REST encryption, at REST encryption. On this one, we're not using IMDS, so that the metadata store for HTTP tokens for the metadata store. We've got missing descriptions. We've got another security group without a description. So that's a number of issues that are now going to prevent this build. So the submitter of this PR is now going to have to go back and either fix the issues, or we're going to have to get an administrator who can force push. So that's introducing tfsec into the CI process. But what if we wanted to catch these issues before they even get to that point? Well, our next option is to do it on the actual machine. We are creating a number of plugins. The plugin for the JetBrains family is going to be coming very, very soon. But so far we've already got a VSCode one, so I'm just going to do a quick demo of that. So first things first, we need to install tfsec into VSCode. So if I search in extensions for tfsec, I can see it there and install it. And what we can see is on the left hand side, we've now got the tfsec logo. So from here, I can run tfsec now, and what it's done is it's run my locally installed version, and it's found a number of issues. So let's have a look at these issues. Let's start with the critical one. So we click through it, we get a description. I can expand that out. We get a description of what the actual issue is. This is that we've got public access to the security group rule. So realistically, it's my Bastion, so maybe I should just put in my IP. So that's good. So let's reload it. Yep, that's fine. That's satisfied that critical issue. So what's the next one? Our Bastion doesn't have encryption. Okay, so what we can do is root block device encryption encrypted equals true. Let's just check that's valid. Let's just init. So Terraform validate, are we okay? So yeah, that's good. So that should fix that. So let's rerun again, and that's happy. So enforce HTTP token IMDS. So I don't really know what I need to do on my Bastion to fix this. So what I can do is scroll to the bottom, and I've got a link, and that is going to take us to the browser where we can see that an explanation of what the issue is, and this is telling us to use the v2 instance metadata service. It's telling us that we need to use require HTTP tokens. So what do we need to do? Looks like we need this metadata block. So then we can take that back to our code and add it in here. And that should, let's just tidy that up a bit. That should, when we rerun it, that's fixed that. Okay, so what's this one here? Our security group doesn't have a description. That's fair. It's not a huge security issue, but it's very useful to be able to see at a glance what your security groups are for. So I'm going to call this Bastion SG. So that's good. And then this last one is that the security group rule doesn't have a description. I don't really care about that, so I'm going to right click. I'm going to ignore this issue. If I had a number of these, I could right click at this level and I could ignore those issues, or I can right click on the low level and ignore all those issues. And that's going to take me back to having no issues to see. So that's really the VSCode plugin. The last thing I want to talk about is custom checks. So custom checks, that's for checking things you care about. So we have a large number of built-in checks that will check AWS, Azure, Google, Oracle Cloud, DigitalOcean. But the things that are fairly generic, is a firewall open, is a bucket, easily accessible, things like that. But we also were aware that users may want to be checking for things that are important to them. They're just not necessarily a standard check. So an example could be that you want to make sure that, you want to make sure that there's always a tag on an AWS instance. And that's in fact the example. So if we look at the browser, if we look at the documentation again, and go to getting started and then custom checks, we've got a description of what the custom checks are and what they do. But essentially we need to add a check file into our .tfsec folder. And then we can put either a JSON definition or we can put a YAML definition in. And then that will include that check in amongst all of our built-in checks. So it's probably easiest just to demo this. So if I take that particular check and go back to VS Code, and what I need to do is I need to create a new folder, a new file with the extension tfchecks either YAML or JSON, and it needs to be in a tfsec folder. So let's call this tags tfchecks.yaml. So that's created our new file. And if I paste in the content, so let's just go through this quickly. So what we've got our code that we're going to call it, and we're going to change this actually to use or tag instances. And this is a custom, so the description, this will be what's reported to the user. So we need a cost center tag. That's what we're saying in this particular one. So let's go with that. We want all of our EC2 and AWS instances to be tagged with a cost center. So in this example, we are saying the impact of not having a cost center is that you can't track the billing. That's cool. The resolutions add a tag to it. We are only interested in Terraform resources. We're interested in AWS instances. We're going to call this severity high. And what the match spec is, so this is saying that we want to ensure that tags contain something that has a value cost center. And then that's the error message that we're going to spit out. Now it's a lot richer, the available match specs. So if we just pop back to the browser, You've got an awful lot down the side here, so you can check things to start with, what they end with, if they're less than or greater than for numeric, if they match regular expressions. You can say that you must have an attribute set, so that would be quite useful if, for example, if a default value on a resource was something that was known to be very problematic, you could say it requires presence, that it always be there. So I would urge you that if you're going to use custom checks, that you go through this documentation, because each of the possible options are covered in here. So if we go back to our example, we're still in VS Code. We left this in a working state, so our current findings are, well, I'll just run it. So it's identified that this bastion here, is missing the cost center tag. So we can see in my documentation, it'll tell me what the problem is and what the resolution is. So if I come down here and in tags just set cost center, spell it right, and we'll go with engineering. If I save that and then rerun, my issue's been resolved. So that's great. Another example we could do is we could add another check. So let's go back to our checks file. We could add another one here, and we could say that the code is that SG ends with SG, bit random, but we'll go with that. Description, security group name ends with SG. Impact, so I'm impact. Resolution, make sure name correct. So what are the required types? So in this case, our required types are resource, and our required labels So let's just check this. So network, it is a AWS security group. So let's go back to that. And a required label is an AWS security group. And this is the interesting bit. So our match spec, let's set a severity is low. So our match spec, so this is how we're going to satisfy the check. So we'll say that we're looking for the name. Let's just go back to our network. Looking for name. So we're saying that name, and we want the action to be ends with, and we want the value to be SG. So let's go back and change this now just to be missing that value. And if we run it, hopefully we've missed a bit, so we need to set an error message. There is a missing part on the name, and we need to do a related links. So let's say HTTPS internal acmecorp.com standards AWS naming. So hopefully that will work. Yep. So it's found a low issue. It's found that network and custom check failed for resource security group. There is missing part in the name. So let's correct that in the name. SG, save it, rerun, and we're good. Everything's fine. To finish up with, I think the key takeaway here is that misconfigurations are bad, and anything is better than nothing. tfsec is a great tool. We think it's very feature rich, and it's actively developed as an open source project. So we are keen to fulfill any issues that the users have. Even if you don't use tfsec, use something, because you don't want to find out you've got a misconfiguration after you've been exploited. So with that, I'd like to say thank you. As I said, this is my first HashiTalks presentation, so I hope it was good. And you're welcome to follow me on Twitter, where I'll be providing more information about tfsec as we add more features and we provide more integrations. Thank you very much.